Hi. So functions are one of the earliest language constructs that we learn in any of the programming languages. So I'm not really going to talk about what function is, why it should be used, or even how it should be used. Rather, in this video, I'm going to explore function for what it really is, which is a data type, a non-primitive data type actually. So we'll see how function behaves when we assign it to a variable and use that variable around, or when we pass function as an argument to a higher order function, or when we return that function from that higher order function. We are also going to see what an anonymous function is, what is its use, and also at the end of the video, we are going to explore function as a scope and how does that help. So let's get started. So let's get started with the three operations of the function. So firstly, we have where we assign a function to a variable. Second is where we pass the function as an argument to a higher order function. And thirdly, a function is returned from a higher order function as the return type. So assigning a function to a variable is quite intuitive in the sense that we have a function here which simply logs a line to the console. This function foo is assigned to the function variable this. So once this assignment happens, this function variable will behave exactly like the function, which means if you have to call the function, instead of calling the function by its name foo, we can use this variable name for its execution. So here is what we do here. So once you execute the function, it behaves exactly like it would have behaved if you had executed the function by its original name foo. The only difference is we execute by its variable, which is assigned to it. So there is really no difference. Let's move on to the second operation, which is passing a function to a higher order function as an argument. So let's start with the higher order function where it accepts as a function as its argument. So what is a higher order function? It's exactly the same as any other normal function. The only difference is that apart from the normal arguments or the return types of a normal function, the higher order function is capable of accepting function types as its argument. And also it's capable of returning function type as its return type. So here we have three functions, foo and bar, which are normal functions. And the third function is a higher order function, which takes a function type as its argument. It takes this argument and executes it inside its definition. So we call this higher order function with the function foo, which is this function. We can call it by passing the function bar also. So we call the function higher order function with the function foo. This takes the argument, the function argument, and then executes it inside. So if I run the code, you will see that we are calling the higher order function here, this line. Then inside the higher order function, it first logs this line to the console, and then finally it executes the function arg, the foo function passed to it, which logs the line hello from foo to the console. This is how a function can be passed as an argument to a higher order function. Let's move on to how a function can be returned from a higher order function. So this is pretty similar to the previous example where it was accepting a function. The only difference here is the higher order function, rather than accepting a function as its argument, will return the function as its return type. So from wherever this higher order function is called, a variable will be there to store this return type in that variable. So then there are two other functions, function foo and function bar, like the previous example. So what we do is we call a higher order function. We don't need an argument here because it doesn't accept any argument. The return function foo is stored in this return func, in this variable. Note that this return func stores the function, the reference to the function that is returned, not really the execution. So whenever you would want to call the function foo. You would still have to call the function like you do with any other function. So when I run this function, you will see that we are calling the higher order function, and then we are returning the function from the higher order function. So essentially, this function foo that is returned from here is stored in this return function, the reference of the foo function. And then in the next line, after logging this, in the next line, we actually call the return function foo. So this is actually a combination of the concept that I had demoed here, where we stored a reference of a function to a variable. Here we stored a reference of the function foo to this return function, and then this variable is called. Essentially, the function is called exactly the same way you would call a normal function. So this is how a function is returned from a higher order function. So let's move on to the anonymous function. Anonymous functions are in fact exactly same like the normal functions that we have been discussing. But there are syntactical differences and also differences in the usage of how you go about them. So this is how a normal function would look like, that we usually call the name function. It has a name foo, and then you declare the function with the keyword function, and then you would define whatever business logic you want to define inside the braces, curly braces. And then at some other point in the code, you would be calling the function. Anonymous functions are usually used where you would want to call the function only once. That means in the name function, once you define the function, you can call this function foo as many times as you want from different points of the code based on the business logic that you require. But there will be situations where you might want to call the function just once and then get rid of it, discard it. In those cases, anonymous functions come in handy. That is what the anonymous functions are used for generally, where the scope of the anonymous functions are limited to a very specific flow. How they differ in the way they look like from the name functions? Anonymous functions are defined and called together, unlike the name functions. In the name function, you can define the function in one part and then call the function in another part based on the requirement. But in anonymous function, the function definition is made first and then called immediately after it, which is why anonymous functions are also called immediately invoked function expressions. They're invoked immediately. So here, you will be defining the function exactly like you would be defining here, function foo and the definition. Note that this whole function is enclosed by a by round braces. The one in line number 9 and line number 12. That encloses the definition of the function. Once that happens, there will be another pair of round braces that actually makes the call. Now let's compare the syntax of the anonymous function and the name function. The syntax of the function executions. So here, if you see, this round brace pair is exactly the same as this. But this foo is replaced by this whatever is written inside the round braces. That means foo is equivalent to this part that we call the function expression. That means even in normal circumstances where we write a normal function, a name function instead of an anonymous function, foo is actually a function expression which under the hood looks like this part, using which we make the function call. That is about the anonymous function. One more thing about anonymous function is you don't even actually have to name the function because you are defining the function and then calling it in the same go.
That's why it doesn't really matter if you have a name or not in the function. So that is what the anonymous function is all about. So I'll quickly go over the same three functions with respect to an anonymous function, that is assigning a anonymous function to a variable, passing an anonymous function to a higher order function, and returning an anonymous function from a higher order function. So it's pretty similar to the name function counterpart. In the name function counterpart, you had a function foo assigned to a function variable. Here, instead of a function foo, it's an anonymous function, an unnamed function. So you'll be assigning that function to a function var, and then you will be calling it. Similarly, while passing an anonymous function to a higher order function, earlier we passed this function foo to the higher order function. In this example, in the anonymous example, the same higher order function will be passed a function, the anonymous function, because it's an anonymous function, because we want to use it just once. Instead of writing the function name, we define the function itself, which is essentially the function foo. Similarly, while returning a function, anonymous function from a higher function, earlier we had returned function foo. Here, we'll be returning the anonymous function. So basically, instead of saying return foo, we would be writing the function expression itself in the return statement of the higher order function. So essentially, a function, be it a name function or an anonymous function, behaves exactly in the same way. The only difference is in the scopes. Name function can be used, it can be called as many times as you want to from different parts of the code. But anonymous functions are usually used where you want to use the function only once. So, whether you want to assign it to a variable, pass it to a function, or return it to a function, at that point itself, you will be defining the function expression of the anonymous function just once and then discard it. So this brings me to the last part of the video, where we see how a function, apart from a non-primitive data type, also behaves implicitly as a scope. We have a function foo, or any function. Whenever we write any function, what we do is we would declare the function with this keyword function and the name of the function, and then we enclose it with a pair of curly braces. So that is what scope is about, right? Wherever there is a pair of curly braces, a scope is created essentially, where anything that declares inside the scope stays within the scope. How does a function leverage this fact? We'll see this here. So here, as you can see, in this entire code, there is a global variable a, which is declared and is assigned a value 10. Then there is another function here, foo, where this variable a is declared and assigned 20. Note that here we use the keyword var again. That means the variable a is redeclared in this part. Redeclaring means inside the scope, variable a is as if it is created freshly. It's as good as creating a variable b or c for that matter. The moment when we redeclare the variable a, this is overwritten. So, whenever we log the output of inside function foo, the value of the variable a, it returns 20. Coming to the scope outside of foo, since this was a variable redeclaration which was done inside the function foo, the global variable a stays untouched. That means outside the function foo, variable a stays 10 and not 20, which was done inside the function. So if you run inside the function foo, you get 20, but in the global scope, you still get 10, which was the original value. If you had not used this variable keyword inside the function foo, the redeclaration would not have happened. That means you would have simply accessed the already declared global variable a equal to 10 inside the foo, essentially modifying its value from 10 to 20. So inside you would obviously get the value as 20. But now, since you did not redeclare but instead just modified the global variable a, so even outside the function scope foo, if you check in this line, you get 20. So that's how we can use function as scopes. Here, since we wanted to modify the value of a global variable only inside the function foo, so we used the redeclaration and the changes were not reflected outside of the function. So that's how a function, apart from being a non-primitive data type, intrinsically allows us for using it as a scope and ensuring that the changes made inside the function, even to global variables, stay inside the scope of the function itself with the help of redeclaration.
So in this video, we covered how a function is essentially a non-primitive data type, how it can be assigned to a variable, passed as an argument to a higher order function, and even returned from a higher order function. And then we saw how an anonymous function behaves, what it looks like, and how it's capable of all the three functions that a name function is capable of. And finally, we saw how a function leverages the scope that it intrinsically creates. So yeah, that's what I wanted to share in this video. I would love to hear about your thoughts and your feedback in the comment section. Thank you so much for watching this video.